Thank you, Dana, and everyone joined the meeting today. I'm Dongyeop Lee, and I'm with Dafeng Kai to present the U.S. Coast Guard Maritime Center of Excellence project. Dafeng was the project architect, and I was the project designer for this project. We will focus on how parametric design workflows were utilized for the building enclosure of the project from the initial design concept phase through project completion. Without much ado, Dafeng will start with site context.
Hi, everyone. So this project site is right at the waterfront of the Coast Guard Academy campus located in New London, Connecticut. So, Coast Guard is essentially a maritime service. So the clients really want us to have this new building reflect their mission and become the bold statement, a gateway for the campus from the waterfront. Next slide. So you can see there's a huge drop. The grading change on the campus is generally sloping down towards the waterfront. So that means make the fixed facade of the building, the roof actually become a very important feature during the design. And this is the shot we taken during the construction, but you can get a sense of the building geometry and the massing in the actual context. So in the presentation, we will dive into more details on how this geometry was generated. And very quickly on the planning, so this is a 20,000 square feet building, 2 stories, and accommodate to several multifunctions. So on the ground level, on the upper deck, we have a welcome center, classroom, and offices. So the main body of the building actually is due north because the direction North Star has a very special meaning for the Coastal Service. And on the ground level, there's a double height boat shop on the backside. There is a science engineer lab and multiple labs and shops for the waterfront operation. The ground level actually angled to respond to the site, the driveway, and the waterfront bank, and creating a sense of arrival and also help anchor the building to the site.
So the design of the project was inspired by the sleek hulls and vessels under full sail, which represent the maritime heritage of the Academy. From the very beginning, we used Rhino and Grasshopper to explore various design options with hydrodynamic geometries. Every project has a limited budget, and this project was not an exception. And we had to come up with the idea of creating a unique and iconic design for the campus based on simple geometries. So using the Grasshopper script, we first set out a series of simple arcs as seen on this image. We then created points on these arcs using sine curves. Sine curves can be found in nature like ocean waves, and they were appropriate for the design concept for this project. The curves were created by connecting these points on arcs. They were then used to trim a barrel-vault roof surface. So the trimmed barrel-vault surface was the driver to create the building enclosure geometry. So it might look complicated, but it is actually based on very simple geometry. So these curves were offset to form surfaces, and then we trimmed these surfaces at the north and the south, which are shown on the right and left side, respectively, on this image. We projected the bottom surfaces to the ground to create wall surfaces. We then divided those wall surfaces into 2 parts, the glass panels above and metal panels below. We created the glulam roof beams following the roof geometry, and we filled between the space between the roof beams with the ceiling planks. And finally, we created roof panels based on the covering the whole roof geometry. The entire building enclosure, with the exception of the deck at the north, was controlled by a Grasshopper definition, as shown in this image. The the project was documented before the Rhino-Inside the Revit came out at the time. So we developed the custom transfer process from Grasshopper to Revit using Excel and Dynamo. I'm not sure there's a lag to play this video, but this video demonstrates how glass and metal panels were automatically generated in Revit by reading the Excel data. The Grasshopper was the main application for controlling the building enclosure design. The geometry was then transferred to SketchUp for visualization and communication within the project team. And the same geometry was transferred to Revit for the documentation by Dynamo and Excel. And right now, there's a Rhino-Inside the Revit came out, so the process is simpler than this. The structural engineer successfully created frames based on the roof surface we provided. However, we had to model exposed glulam beams for the documentation. Those beams were transferred from Grasshopper to Revit automatically using the same method shown in the previous video. The work points were critical to describe the geometry of cotton panels. All these work points were also automatically transferred from Grasshopper to Revit. Additionally, tagging was automated by running a Dynamo player script. If you're trying to manually add these tags, and we had to kind of iterate this process. We had to optimize design, and we had to iterate the documenting process multiple times. So the automating these workflows were very helpful for us to optimize the design. The work points were also used for the roof geometry, and they were set at the interval of 3 feet for the north and south axis. The project team coordinated with the glulam fabricator to decide how to set up work points and parameters for glulam beams. We spent a good amount of time documenting glulam beams to minimize any potential construction issues. These tables display the XYZ coordinates of all the work points used in the project, and all these coordinates data was also transferred from Grasshopper to Revit automatically. This page shows a few diagrams of the roof and soffit assembly on the right side. The force colors on the soffit surfaces at the bottom indicate the range of deviation from flat planes, with red representing the highest deviation and green being flat surfaces. All these actually the most complex surfaces were soffit surfaces because they are double curvature surfaces, but we checked the deviation from flat planes, and they were all within the tolerance.
So just want to very quickly go over all the renderings we have. So this is the building you see from the waterfront. And this is from the waterfront access, you see the building. And this is you coming from the campus across the railroad, you're going to see the building and where are the main stairs. And this is the backside of the building where we have this double height boat shop and tennis shop. And this is the interior. You can see we have the heavy timber structure and made the reference to the traditional way people make the boats and all the terminology all exposed to beam. So this is the timeline photos we took showing some critical phase during the construction, from very beginning, the steel structure erection to the metal deck installation and roofing, and last page showing the final finished roof panel start installed. And next slides, this was taken early this year, February, when we went on site and see all the lighting installed and tested on site. I tried to pair the photos I took during the February with where the rendering we show, so you can see the consistency between the design and the final products. So this is again coming from the campus across the railroad. And next one showing with the lighting on that day. The next is showing where you access the building from the waterfront. And again, with the lighting on. And this is a backside, people still working on the sulfate on that side, and that's where the double height bow shop maintenance is. And this are a few night shots with, with the help of this lighting, actually the unique geometry of the building and the massing, the texture was magnified. The next slide, I have a few more night shots. It's just like I have to admit I'm very addicted to those photos because really the lighting helps to showing the geometry of the building. And this is the interior shots we took. And you can see all this exposed the heavy timber, how they're relevant to the boat shop structure, the boat structure. And I want to pause here a little bit because, from the drawing to the finished products, as architects, we mostly rely on the submittal review to control the process, make sure the design was properly executed on site. But this part is especially unique because all this parametric design process. So even though we bring the contractor on board during the design phase, we talk through all the design intent, but really to carry that intent into reality is a challenge in a very different level, right? So if you think about the building as organic body, so I try to categorize all the submittal as 3 types. So the very first one is a bone. It's about including the foundation, concrete slab, the steel structure, which we're showing here. It's actually set up the basic framing for the project. So all the steel columns is in a 12 feet spacing, compared with all the finished panel, we have every 3 feet spacing and the segment. But without setting up all the structure on the right location, on the right height with that grid, you're going to lose the whole reference point for the whole construction. So this is very critical submittal. And next slide. A second category of submittal that I would think is a muscle of the project, and this one, which is co-form metal framing submittal, is the most important one for this project because we rely on the co-form metal framing to frame the whole building facade with every 3 feet segments for the project. And that's basically you need to lay out all the structure on the plan with certain segments, and you almost set up the certain height so they match the metal panel and the curtain wall height. So that's where those XYZ kick in, and you need to review all this information compared with our documentation. And next slide, it's also same thing. We also rely on co-form metal framing to form this compound curve on the soffit. And so we have to, based on our detail, to pick certain key point, and then the contractor can use that key point and set up XYZ coordinates. And then we can compare their coordinates with our data point in documentation to make sure everything consistent with our design. And the third category in the submittal, I would think, is scheme, right? Because now you got to the finished products of the project, you want to make sure everything comes together nicely. And that's, like most of the project have, we do this mock-up to make sure all the detail looks right, everything comes together nicely before we really apply all these things into a real building. And a lot of detail is at this level you need to pay attention. For example, for this project, we have the seal of the curtain wall continue stepping down to form the curve along the building facade. And then you need to think about, okay, the review of the metal panel cannot be aligned with the center of the curtain wall. Otherwise, people cannot construct it. So you have to make sure all those review align with the one side of the molding so you can make every detail constructible. And again, like on the roof, you need a gutter, how we can conceal the gutter nicely, follow the geometry of the roof curve. And there's going to be a snow guard, there's going to be a snow rail, and you can see from the photos, the snow rail follow the geometry and with a similar segment. And also the snow pad actually try to, barely visible from the photo because they all align, they are at the one point of the diamond shape of the roof tile. And the last but not least, of course, the lighting is very important for this project. How you can detail the lighting, given the certain surface, they can mount it without conflicting with the building geometry, and how you can conceal at both top and bottom, but make the lighting complementary to the building geometry, but not conflicting with the building geometry. And this is the last photo I want to add in the end, because this project would not look like this without great contractor actually took ownership every step of the way. This photo I received from the one day at like 6 a.m. in the morning from the project manager, the contractor. They didn't even say a word in the email, but I can feel he's very proud of this project. And, you know, I love this photo because we feel the same way. It's like every single party in this project needs to take ownership for this one. And so then we can carry the concept through the way to the completion of the construction. And with that, I think that's the whole presentation we have.
Well, I'll say that you're definitely getting a lot of compliments on how beautiful it is. It's so crazy how the real photos look like renderings, right? I mean, they don't. It looks like you plopped a tractor or whatever in the photoshopped it in. You know, it looks just absolutely stunning. Can you talk a bit about how you translated the geometry over the fabricators in terms of some of the roof panels and things like that? I mean, did you share the actual models? Were they getting you know, the Rhino, the Revit, those types of things? How are you translating that to them outside of the shop drawings?
Oh yeah, well, of course, like Dongyeop said at the very beginning, like in the design, we have the panel size 24 by 24. But during the construction, we realized the maximum panel size we can go is 21 by 21 based on the availability of the materials. And then we have a talk with the fabricator, make sure they understand, you know, we want to start a panel centered with the roof geometries, and we set up several design guidelines for them. And then they can use the actual panel size and do their shop drawing. And then they send out the revised shop drawing based on our design documentation, and then we review that. And there's a back and forth. I mean, I think we reviewed the roof shop drawing probably 6 times. Unbelievable. Part of the reason because this building is waterfront. There are a lot of the code requirements, wind load you need to meet, and there are back and forth on that. But overall, you know, because it's not a typical building, it's a parametric design process, it adds another layer of the complexity to the reviewing of the shop drawing.
Interesting question. Did the state require the BIM? Did you have to send over the Revit model or anything like that? Or was it even, you know, did you required the contract? I mean, I guess the Coast Guard wants it.
No, this is the project in the Coast Guard, which is a federal land. So oddly, like we don't design this building to meet state requirement. They don't review the drawing, but of course we're designing the building in Connecticut. We check all the state requirements. We gave all the Revit model to the contractor so they can use and pass that to all the subcontractor for all the information to share. But it's not required by contract. And honestly, like the Coast Guard, they only require CAD drawing. So we actually convert everything back to CAD for the delivery.
Yeah, sadly, I would figure, right? That's government for you. Looking back, right, hindsight's 2020, what would you guys have done outside of course, product and software advancements? Right now we have Rhino inside, we have a few other tools that SmithGroup is using that might have made the process smoother. But is there anything else outside of that you might have done to just done differently in general?
I'll leave that question to Dongyeop.
Yeah. I think the process could be smoother because there right now the transfer between Grasshopper and Revit is simpler with the Rhino inside, and also the proving ground had the app conveyor to make it even easier. But the one thing that we kind of had issues was it was a small issue, but we had to there was another person touched the Grasshopper script, and there was a point that we had to track the kind of the change between the different versions of grasshopper files. So I think when you do this, you probably need to freeze the document, the model, the Rhino model and grasshopper script at some point, and use that as a reference point. I mean, it's not just for grasshopper or Rhino files, but for documentation, you have to set up that kind of a reference points for every change. I think that is something that I would recommend to everyone who's interested in this process.
And it's just so, I mean, it's so incredible the way that like you're saying, the snow cleats and the gutter and all of that was fabricated as part of that process. I mean, that's just, mind blowing. What was the wood that was used? The material itself.
You mean the wood structure? What wood used?
Or the wood paneling on the exterior? What can you talk to any of the materials that were used? Or the interior? Maybe they're talking about the barrel vaulting.
Yeah, the actual structured wood is glulam beams that come from Canada.
Glulam.
But wood cladding itself is, I think it's a Brazil teak. The reason we use that is because most boats in old days was made with teak. The major donor of this project think we need to use exactly the same wood for that specific reason. And
that was another case, right? Is that the donor was they wanted it to be kind of a innovative structure.
Right. He pushed us to this innovative design process because he really wanted this building to celebrate the mission of the Coast Guard. And that's why the boat's geometry, structure, and everything we kind of try to relate to that concept.
I'm guessing Kobe was not required because no state mandates, right? I mean, if it wasn't tied to the state, I'm guessing it wasn't Kobe. No,
No,
I wouldn't think so either. Was it LEED? Did you do any LEED certification or anything like that?
It is LEED silver for sure. We're trying to get LEED gold. We're in the final submission phase, so hopefully we can get LEED gold, and we're going to hit back in 2 weeks.
Well, I'll say this is an incredible amount of questions and comments for a presentation. I mean, like I said, I've seen this presentation. I could see it again. So amazing. So thank you.
I just want to add one thing quickly.
Yes, please.
For the future reference, I think, every project has a budget, as we have for this project. We try to create some complex look with a simple geometry. And we try to understand how we can use conventional construction method to realize that during construction, to execute in the construction. So I think for any project team, you have that money. Of course, if you have a lot of money, you don't even care about money, that's a different story. But every project has a budget limit. If you want to make sure your design concept can be executed in the real construction, you want to bridge two things together, try to find a middle way to handle those complex things and merge that into a conventional construction method. I think that's just one strong feeling working several years on this project, what I got, and just want to, just say that out to anyone want to keep using the Dynamo and the Grasshopper as a design way, but have sometimes don't know how to make the real project use that method.
Well, thank you again. Amazing presentation. Dongyeop, Dafeng, thank you so much for your time.
Thank you.